Okay. Let us find nth derivative for a function like if y equal to picture clear sign y okay. If y equal to x to the power n, then find nth derivative of y. That we write it as dny by dxn. We want to find nth derivative of y. Now, if y equal to x to the power, let's write m here. We want different n and m. So question is, if y equal to x to the power m, then find nth derivative of y with respect to x. Let's find first derivative, dy by dx. We just need to differentiate both sides, and we have m into x to the power m minus 1, and that's equal to, we can write it as factorial m by factorial m minus 1 into x to the power m minus 1. What about second derivative, d2y by dx square? If you differentiate it first derivative, then you will get second derivative. ddx of dy by dx is d2y by dx square. So d2y by dx square is nothing but ddx of dy by dx, and that is your ddx of m into x to the power m minus 1, and we have constant that we can take out from the differentiation, and if you differentiate x to the power m minus 1, we'll get m minus 1 into x to the power m minus 2. That we can write it as factorial m by factorial m minus 2 x to the power m minus 2. Of course, here we should assume m greater than or equal to 2, because if you have y equal to x or x square, if you just write y equal to x, and if you double differentiate it, then you get 0, not this number. So here I should write m greater than or equal to 2, and here I should write m greater than or equal to 1. What about third derivative, d3y by dx cube? If you differentiate d2y by dx square, then you get d3y by dx cube. So you just differentiate it. Constant as it is, you don't have to differentiate the constant. And then x to the power m minus 2. If you differentiate it, you'll get m minus 2 x to the power m minus 2 minus 1, n x to the power n minus 1, that's the first one. Here if we assume m greater than or equal to 3, then I can write it as factorial m by factorial m minus 3 into x to the power m minus 3. Note it, if I write first derivative, I have got minus 1 here. Second derivative, we have minus 2 here. Third derivative, we have minus 3 here. So if we take nth derivative, what should we have? We should have factorial m by factorial m minus n into x to the power m minus n, comma m greater than or equal to n, and n is greater than 0. If you take 0th derivative, okay, you can write n equal to 0 as well, no problem. Okay, similarly, let's do the second question. If y equal to ax plus b to the power m, find dny by dxn. Answer, we'll follow the procedure as it is. Dy by dx, just differentiate it both sides. M into ax plus b to the power m minus 1 into d dx of ax plus b, that is just a. What about second derivative? Oh, that can be written as factorial m by factorial m minus 1 ax plus b to the power m minus 1 into a to the power 1. What about d2y by dx square, the second derivative? M as it is, constant as it is. A is also a constant, we write as it is. Let's differentiate it once again with respect to x. M minus 1, oh, here I should have m greater than or equal to 1, and here ax plus b to the power m minus 2 into a. So that we can write it as factorial m by factorial m minus 2 something missing here. Oh, factorial m by factorial m minus 2 whole thing into ax plus b to the power m minus 2 into a square. Now if you continue this, okay, we can observe that when you take first derivative, you have minus 1, a to the power 1. When you take second derivative, you have minus 2 a to the power 2. In general, when you take nth derivative, you should have dny dxn equal to factorial m by factorial m minus n ax plus b to the power m minus n into a to the power n. Okay, that goes. Okay, next let us look at the question. If y equal to e to the power ax, then find yn. That is nth derivative of y with respect to x. Let's do it. If you differentiate it both sides, dy by dx is equal to e to the power ax into d dx of e to the power d dx of ax. That is just e to the power ax into a. What about double derivative? Same thing, we differentiate it again, e to the power ax into a square. If we continue it, we'll have nth derivative e to the power ax into a to the power n. Okay, pretty simple. Let's look at another one. If y equal to 1 by ax plus b, then find y-nth. Answer. Okay, you can write differentiating both sides with respect to x, dy by dx equal to 1 by ax plus b is nothing but d dx of ax plus b to the power minus 1. And that's equal to, the formula is nx to the power n minus 1. So your n is minus 1 here, minus 1. X is your ax plus b to the power minus 1 minus 1. But again, we need to differentiate ax plus b as well. Okay, that goes the first derivative. What about the second derivative? Minus 1 into your d dx of ax plus b to the power minus 2 into a. Constant can always be taken out of derivatives. So I have minus 1. Apply the formula minus 2 into ax plus b to the power minus 2 minus 1 into derivative ax plus b is a, and this a, if we copy it, we have that. So you have factorial 2 by ax plus b to the power 2 plus 1 into a to the power 2. Double derivative, you have factorial 2. Single derivative, you have factorial 1. Factorial 1 is just 1. We did not write that. Single derivative, a to the power 1. Double derivative, a to the power 2. Let's do one more case. Let's do triple derivative. d3y by dx cube equal to we just need to differentiate it again. So let's take the constant out and write it as d dx of ax plus b to the power minus 3. That we can write it as minus 3 into ax plus b to the power minus 3 minus 1 into a. That we can write it as factorial 2 into 3 will give you factorial 3, of course minus 1 of course as well, and you have a cube here, and you have 1 by ax plus b to the power 3 plus 1. Third derivative, 3 plus 1, a cube factorial 3 and minus sign. Second derivative, factorial 2 a square x plus b to the power 2 plus 1. So what can we say? We can say nth derivative must be equal to, if it is even it is positive, if it is odd it is negative. That's what minus 1 to the power n is. Okay, that's what we have. Minus 1 to the power n, factorial n, ax plus b to the power n plus 1 on the denominator, and a to the power n. Okay, let's look at another question. Yeah, this is interesting. If y equal to sine ax plus b, then find nth derivative of y. Answer. Well, dy by dx, if you differentiated both sides with respect to x, derivative of sine is cos, ax plus b into derivative of ax plus b is just a. That doesn't look something like y. Y is sine, and here we have cos. Do we have some relation between sine and cos? Well, sine 90 degree plus theta is your cos theta. This cos can be brought back or can be written in terms of sine with this identity. So how shall I write here? I should write it sine. In calculus, we don't write degree. We work in terms of radian. 90 degrees pi by 2 plus 90 degrees pi by 2 radian. Okay, so ax plus b plus pi by 2 sine 90 plus theta gives you cos theta. A as it is. Okay, dy by dx we have expressed it in terms of sine. Only thing is angle has increased by 90 degree. What about double derivative then? d2y by dx square. Well, differentiate it again. Derivative of sine is cos. And derivative of ax plus b plus pi by 2 is just a. So that can again be written in terms of sine. Sine 90 degree plus theta is cos theta. So this cos theta, I want to write it in terms of sine 90 plus theta, extra 90 degree. Extra 90 degree, and you get it back. So that is sine ax plus b plus how many times we had pi by 2? We have got 2 times 90 degree. So 2 times pi by 2 into a square. What about third derivative? Again you differentiate sine, then we get cos. But by chain rule you will have a here. Again you write cos in terms of sine. Sine 90 degree plus theta is cos theta. So this cos, when I write it in terms of sine, I have to bring one more 90 degree here. That's sine ax plus b plus 3 pi by 2 into a cube. Now if you proceed it, first differentiation 1 times pi by 2, second differentiation 2 times pi by 2, third differentiation 3 times pi by 2. If you take nth differentiation, you should have sine ax plus b plus n into pi by 2 into a to the power n. Well, the similar thing you can do for cos as well. If y equal to cos ax plus b, then you can try it yourself. Y nth should be cos ax plus b plus n pi by 2 into a to the power n. Okay, similarly you can derive other identities. Let's proceed to Leibniz rule or Leibniz theorem. What does Leibniz theorem says? If u comma v are, what are we doing? We are doing Leibniz theorem. Leibniz Leibniz theorem. If u comma v are two function of x, then uv, let me write v using black pen. Where do I have the black pen now?